Part 22f1fa19a3 Line 22f1fa19a3 Longitude of the ascending node state vectors Wow Seti. There's the alien radio signal and the keywords for longitude of the ascending node. And here is a picture. We have the celestial body, true anomaly, argument of parapsis, reference direction, longitude of ascending node, plane of reference, inclination, ascending node, and orbit, which is this area here. That's your orbit there, okay? So quotes from Wiki. The longitude of the ascending node is one of the orbital elements used to specify the orbit of an object in space. It is the angle from a reference direction called the origin of longitude to the direction of the ascending node measured in a reference plane. Commonly used reference planes and origins of longitude include: for a geocentric orbit, Earth's equatorial plane as the reference plane, and the first point of Aries as the origin of longitude. In this case, the longitude is also called the right ascension of the ascending node, or RAN. The angle is measured eastward or is seen from the north counterclockwise from the first point of Aries to the node. For a heliocentric orbit, the ecliptic as the reference plane, and the first point of Aries as the origin of longitude. The angle is measured counterclockwise as seen from north of the ecliptic from the first point of Aries to the node. For an orbit outside the solar system, the plane through the primary perpendicular to a line through the observer and the primary called the plane of the sky as the reference plane in north, i.e. the perpendicular projection of the direction from the observer to the north celestial pole onto the plane of the sky as the origin of longitude. The angle is measured eastwards or is seen by the observer counterclockwise from north to the node. In a case of binary star known only from visual observations, it is not possible to tell which node is ascending and which is descending. In this case, the orbital parameter, which is recorded in the longitude of the node, which is the longitude of whichever node has a longitude between 0 and 180 degrees. The calculation from state vectors. In astrodynamics, the longitude of the ascending node can be calculated from the specific relative angular momentum vector h as follows. Now there's the mathematical equations. Okay. Here n equals nx, ny, and z is a vector pointing towards the ascending node. The reference plane is assumed to be the xy plane, and the origin of longitude is taken to be the positive x-axis. K is the unit vector 0, 0, 1, which is the normal vector to the xy reference plane. For non-inclined orbits with inclination equal to 0, the little funny mark is undefined. For computation, it is then, by convention, set equal to 0. That is, the ascending node is placed in the reference direction, which is equivalent to letting n point towards the positive x-axis. Okay, so we'll go on to the next video to find out more what this means.